Welcome. So here's the problem. I'll just let you look at it and just let you think about your life for a second and see what's about to occur when doing this problem. Okay, I'm just a little kidding. But by working through this problem, we come up a lot of times and we try something and it just gets crazy and we're like, that's why I hate math and it's so hard. So we just got to kind of step back and think about what are we trying to accomplish? We're trying to make one side equal to the other side, right? And we want to show, that one side's equal to the other side. We want to verify. And so, we pick complicated side. They both look pretty much exactly the same. I wouldn't say one's more complicated than the other. Our trig identities, we can't really apply our Pythagorean identity. There's no squares in there. We can look at our quotient identities or our reciprocal identities and know that tangent and cotangent are reciprocals of one another. And by looking ahead, what I would want to do is I would say, well, I want one side to look like the other side. And I'm just going to start with the left side just because I have a little more space working the left side. So I'm going to simplify the left side. And if I know I want tangents to look like cotangents, well, then that means I need to rewrite them in cotangent form. So I'm going to have 1 over cotangent of x plus 1 over cotangent of y divided by 1 minus 1 over cotangent of x times 1 over cotangent of y. All right. Now remember, cotangent of x and y are not like terms, so we can't combine them. But neither do we actually even want them to be, because you see over there, they're going to be separated. And I could put parentheses around the y's while I'm at it. So let's go and see here. One thing that we want to get rid of is I still have cotangents as my denominator. So how about let's just try to get the cotangent of x and y off our denominator, right? Because we want cotangent of x and y, but we want them in a numerator. We don't want them under 1. So what I'll do is I'll multiply by cotangent of x times cotangent of y on the top and on the bottom. And I'll actually put that up top so you guys can see that it's going to be that's as your numerator, right? That's over 1. And then let's kind of put it as parentheses so we can remember, we need to apply distributive property. So here, we're going to put these over 1. So when multiplying across, let's do my numerator first. I'll have cotangent of x times cotangent of y all over cotangent of x plus cotangent of x cotangent of y all divided by cotangent of y, divided by, in the denominator, I'll now have cotangent of x, cotangent of y, right? Because again, I need to apply distributive property. And then when I multiply here, you'll notice I'm just going to have minus cotangent of x, cotangent of y, which is my numerator. And then my denominator, I have cotangent of x, cotangent of y. So this is very fun for me to keep on saying this all over and over again. But I wrote all this stuff out here because I didn't really want you guys to be looking at this mental math and get stuck. I want to write it out there so you guys can see, those two terms divide to 0. These two terms divide to 0. That's going to be the same. This divides to 0. I'm sorry, not to 1. Divides to 1, divides to 1, divides to 1, divides to 1. Therefore, my final answer is going to be cotangent of y plus cotangent of x divided by cotangent of x times cotangent of y minus 1. And let's look to our right side. Is that exactly what we need? Yes, it's exactly what we are looking for. That's x, y. You can rewrite those, switch them around, and you'll get the exact same. So therefore, our identity is verified. Thanks.